There are three types of computers. There's computers, what we already think of, which are machines that are able to compute. And then there's a new type of computer, which we're hearing about all the time, AI. Now we primarily see this as large language models, and we see diffusion models, which can create pictures. But at the end of the day, these are still machines that are doing things, but they're doing things in a way that is different. It breaks the way that we normally think about computers. So much so that think that it's almost not helpful to think of them as a traditional computer. They're a new type of computer, a new paradigm of computing. We'll talk about some of those differences in a bit. Now, the last type of computer has been around all along, but we don't think of them as computers. What is that last type? It's you and me, people. Yes, we are also computers. Believe it or not, before we had machine computers, we had people who their job was to compute things, and we called them computers. For example, the mathematicians who calculated the trajectory of spaceships on the way to the moon, they were computers. They were people who did math and made those calculations. Now, of course, fast forward, and we're not doing those kinds of calculations by hand anymore. We're having machines do those calculations for us. And that's great. We're able to do all kinds of calculations that we never would have believed would be possible today. But of course, there's disruption. There are people who used to do that for a living that there's no way that you can get that as a job today. And we've seen that in several different areas in the last 100 years. Now, what I would like to do is I'd like to talk about what are the differences between these three types of computers. And I've found a bunch of different ways that we can compare and contrast each one of these. Now, the first one is the one that you're going to hear a lot from marketing and ads, and I think it really is the least helpful way to think about this. In fact, I think it's just a downright bad way to think about this. When you go to a store, they will market things as smart, and that implies that other things are not smart. So, for example, you're going to get a smart TV. Well, I have to have the smart TV. Otherwise, that must mean I have a dumb TV. Before that, we had smartphones. Well, that must imply that my flip phone is a dumb phone. And we just slap on labels like smart to things. Now we're doing the same thing with slapping on the label AI. AI is incredibly imprecise as a label. It means a different thing in different decades and different times. It's constantly changing. It's because we're using this word imprecisely. I think that this is an incredibly bad way to think about things for several reasons, and we'll get into some of those here. Now, what are better, more helpful ways to think about the differences of these three types of computers? Well, how about this? Programmatic versus intent-based versus pattern matching. Because that's what's really happening here. Okay? Computer machines, the way that they have worked for most of our lives is that they were programmatic, and they still are programmatic today. What that means is I give it a program. I give it step-by-step instructions. Do this, then do this, then do this. And every single step is written down by some human somewhere. It has instructions for every single step. It never does something unless it was explicitly told to in those programming instructions. Next, we have what LLMs are doing. LLMs are able to do things even if you did not explicitly tell them to do it. And that can totally break the way that we think about computers. Because in the past, computers always only did something if we explicitly told it to. But now, who knows what it's going to do? And it feels really smart. It feels like I can't believe it just did that. I didn't even tell it to do that. It must be a genius. But what's actually happening is it's pattern matching. You probably already know this, but AI is trained on lots and lots and lots of data. And so, if it has seen that in its data anywhere, then it's going to copy that behavior. So it feels like it's really intuitive. It feels like it's really smart and reading between the lines. But what's actually happening is that that behavior is already in its training set. And then finally, we have humans. And what we do is we have intentions, we have goals, we have things that we want to do, and um, tasks and outcomes that we're trying to achieve. And then we improvise, we innovate, we problem solve. And what LLMs and AI are currently able to do is they're really good at approximating that. And they're very good at mimicking the way that humans behave, but there are important similarities and differences. Some other ways to think about the differences: predictable versus unpredictable. Predictable versus unpredictable. We AI is getting huge. It's all about all the talk right now, and everybody's blowing up about AI. But one major problem of AI is it's not predictable, which also means it's not reliable. If I, when I turn on the alarm clock, the old school alarm clock in my house, I know that whatever time I set it to, that's the time that it's going to turn on. If I tried to do the same kind of thing with an AI, well, by the way, there isn't an AI that is thinking in terms of time currently. But if I gave it an instruction, let's just say Siri, for example, if I gave it an instruction, maybe it will do what I want it to, or maybe it will interpret it in a totally different way. It's just not reliable. Let me ask you this. Who do you want to handle your medical services? Who do you want to decide whether or not you should get this medication or that medication? Do you want a deterministic, predictable system? It may not be the smartest thing in the world, but whatever you tell it to do, it's going to do exactly that. Or do you want a slot machine? Because that's basically what AI is. Who knows what it's going to do? AI is just not very predictable. You know who else isn't very predictable? Humans. Humans can have a huge degree of variability. That's both a good thing and not such a good thing, depending on what you're trying to do. AI is, um, well, so the next paradigm will say that machines are deterministic. That means if I give you the exact same inputs, I will get the exact same outputs every single time. And AI kind of sort of not like that. If I put in the exact same prompt in the chat GPT, I'm going to get a different answer each time. It's not deterministic, okay? But why is it not deterministic? It's actually not deterministic because under the hood, the developers of ChatGPT have put in a little bit of randomness on purpose so that it will behave differently each time. And in machine learning, There will be, when you actually use the raw model itself, there will be a parameter often called a seed, and that is the random number, essentially. You can change the seed number. If you had control of the actual seed number, then you actually would get a deterministic result every single time. Given all of the same inputs plus the exact same seed, you would get the exact same outputs every single time. So, um, traditional machine computing is deterministic. AI can be, but it really depends on the interface. And then humans, on the other hand, we are not deterministic. Um, if you give any human the exact same inputs, you're going to get a different output every time. Why? Because we humans, you can't really give us the exact same inputs every single time. If you ask me a question today, if you ask me what is my favorite color today, all right, that's your input. You ask me what is my favorite color, and then I say green, obviously. Well, um, that's my answer today. But tomorrow, when you ask me what is your favorite color, it's the exact same prompt, exact same question, exact same input, but I remember the last time that you asked that. And I have a different level of energy. I have a different level of happiness. I'm going to give you a different output. Okay, so um, traditional computers are deterministic, and uh, LLMs, AI, are not really deterministic, but they are probabilistic. They are something is more probable than another thing. And um, humans are a little messy, a lot more messy. Okay. Next thing, stateful versus stateless. This is kind of what I was talking about in the last example. Humans always exist in a context. We exist in a place, in a time. We have an emotional state. You can never perfectly control all of the variables. The variables are out of our control, which then means that the outputs are out of our control too. You can't perfectly control another human being. Machines and AI, on the other hand, we can perfectly control every single input that goes into a machine or an AI. And given those exact same inputs, we will get the exact same outputs every single time. Humans are stateful, which means that we exist in a certain state, and AI and machines are stateless, right? The there we have all these solutions where we're saying like, oh, we're giving the AI memories. No, we're not. What we're doing is we're changing the inputs. We have some sort of text file and we're writing to the text file, and then that's given as part of the prompt into the model. All that we're doing is just changing the inputs. Okay, and we have a little bit of extra tooling to make it easier to change those inputs, but it doesn't actually have memories. It has tooling that is designed to mimic the way that our human memories work. Okay, next uh, paradigm, programmable versus trainable versus experiential. Machines are programmable. Again, I can give it step-by-step instructions and they will follow that. AI doesn't work that way. You don't give it step-by-step instructions. What you do is you train it. You give it a ton of data and then it trains, or somebody trains it, right? The average user is not the one training it. And then the model follows the training. It does whatever was in the training. But this is important. If you give it some sort of input that was not covered in the training at all, then that model will have no idea what to do. And it will do all kinds of crazy wacko things that you never would have expected. And it will look really dumb. Okay? But this is the key difference between humans and AI is we humans have the ability to come into completely new situations and innovate. We have the ability to extrapolate lessons that we learned from one place and then apply it into the other. Now, a lot of people would say, well, AI can do that too. Kind of, sort of, yes, no. What AI can do is the AI can take lessons learned from totally different domains and then combine them together. And that is really great. That's actually, we humans do that too. But if there genuinely is nothing like it in its data set, then the AI is not going to be able to figure that out. The reason why our current AI um, has been able to do so many things that we thought were impossible is simply because it really is in its data set. It just has such a gigantic data set. But when you ask it to do things that are not in its data set, that's when it struggles and fails. So right now, AI is really good at answering questions. Well, you know why? Because it's trained on the internet. And the answer to almost every question is somewhere on the internet. But you know what's not on the internet? Um, the actual spatial awareness within 3D space. There's not a whole lot of websites that are telling me exactly where to look inside of my Walmart, which shelf to look for this particular item. The AI is not going to be able to help me with those kinds of things because that's typically not in its training data set. Probably will be eventually. At the moment, it's not really. So, understanding within physical space is currently something that AI is not great at, and that's because it's not in its training set. Next paradigm, logical versus probable versus hybrid. There's a lot of overlap between the last things that we were talking about, but again, machines are rigid, they completely follow instructions. That's because they're logical. The AI is just following what is probable. Whatever was most likely within its training data set, that's what it's going to do. And then us humans, we have actual experiences. We remember that time that I did this, and I felt this, and I thought this, and I did this, and then this is what happened. We have experiences. Those can seem very similar to training data, um, but they are not the same. Okay. Um, but the other thing that I want to draw your attention to is that humans have the ability to be logical, just like machines. In fact, we were logical way before machines were logical. Humans also have the ability to think in probability terms. We have the ability to think, oh yeah, that sounds likely, or that sounds less likely. But on top of that, we can think in a lot of other ways. We can think emotionally. We can think creatively, in so many different ways. And we can fluidly switch between different ways of thinking. And at the moment, machines and AI, not really so good at doing that. Last one that I want to draw your attention to, machines and AI are what I call relentless. They just keep going and going and going. They're not going to stop. They don't get tired, right? Um, us humans, we get tired, right? Um, so we are what I call fatigable. We can find something monotonous. We can just need more sleep. We can need more food. Um, we can feel fatigue. Now, the AI can tell you that it's tired, but really it's not tired at all. What it is it's just outputting more text. that says I am tired, but there is no internal feeling that it feels. So those are some of the differences. And when we look at those differences, that shows us different strengths and weaknesses for each one of these types of computers. And the key insight that I want you to get from this video is that we should be using the right tool for the job. Whatever the task you're doing, there is a type of computer that is better suited for it and one that is not better suited for it. The more that we understand the differences between machine computers, AI, and us human computers, the more that we can understand what our strengths and our weaknesses are. I, for one, am super glad that we do not have humans calculating trajectory to the moon on paper anymore. Why? Is it because computers are so much better at it than humans? Well, actually, yeah. Computers have shown themselves to be far more capable at computing um, just straight math problems than humans can. The computer does it faster, does it with less errors. They don't run out of pencil. They just use electricity and then spit out outputs. Um, so I do prefer it for all of those reasons, but there's an even bigger reason, which is all of those humans who were calculating trajectory to the moon, now they can do other things. And this part's important. I'm sure, I'm positive that it must have been really hard for those people who lost their jobs. It must have been really hard that they spent years and years and years honing their mathematical ability and being able to make those incredible calculations. I can't make those calculations. But the bright side is that think about all of that talent and effort that they were using for those calculations, and now they have all of that talent and effort free to do other things that we only could have dreamed of. That's really incredible, right? Think about, by the way, we still have humans doing math on paper, yes, and on chalkboard. Um, we still have humans doing math today, right? The top mathematicians in the world are not using only computers to do all of their math for them. What are they doing? Theoretical physics. We are still using math to discover particles decades before we've actually observed them. The Higgs boson particle, for example. Well, those mathematicians who were calculating known things before, now the machines can handle calculating the known things, and we can have those same mathematicians move on to calculating the unknown things, or doing all kinds of other amazing things with um, with their minds, and that I think is a positive thing. Um, the key unlock that I want you to get from this is that we should be using the right tool for the job. If we have something that a human could do today, later on we figure out how a machine could do the same thing, then that frees the humans to do things that machines can't do today. On the other hand, we should not be handing over things to the machine just because the machine can do it. There are things that humans are better suited at doing, and we should find those things, and that's where humans can provide the most value. In particular, I would say um, Machines are best suited for tasks that are highly predictable work. And AI is really suited for things that are not predictable, right? It doesn't have a step A, step B, step C predictable workflow. So AI is pretty good for unpredictable things. However, we've all seen in the past that when it comes to actual creative work, it's not so great. It's really good at regurgitating creative work that somebody else did, but actually coming up with novel solutions and new creative ideas, it's not so great at that. What should humans do? What should we use humans for? Well, here's what I want to say. Let's not think of humans as something to be used. We shouldn't be using humans. We shouldn't be using others. You shouldn't even use yourself. Humans are not tools. Machines, they're tools. AI, they're tools. Don't confuse machines and AI with people, but also don't confuse people with machines and tools. So, what kind of work should we humans be doing? My answer is choose the kind of work that you want to do. Find people who want to do the work that you don't want to do, right? This is a very personal choice. I can't tell you what you should be doing. You should find where you find the most enjoyment, yes. But also enjoyment is not the only thing that matters. You should also be looking for where can you provide the most good and positive for your life and for those around you, right? There is so much good work to be done. And so much of that work, believe it or not, can't be done by AI or machines right now. That's the work that is valuable. And I would recommend that's the work that you should be looking for. Somewhere out there is something that only you can do. Not even another machine or an AI, not even another person. Look for something that you can do that nobody else can really do. And it really is out there. So you got to look for it. The next insight that I want to bring out is we should be fluidly switching between different types of computers. Use the tool that is best for the task. And as you've already found out, I'm sure, whenever you have a task, tasks are made up of a bunch of little tasks. And each one of those little tasks, some are better suited for machines, some are better suited for AI, some are better suited for humans. You should be switching for each of those. And that can feel like a big hassle to switch from one to the other. But if you have the right tooling, it can make it much easier to switch back and forth between different ones. So, for example, you will hear there is a term called human in the loop. There are AI agents that are designed to do a bunch of steps, but then stop and then ask the human for input. You can implement this in a variety of different ways. Um, you can instruct an agent to send you an email and ask you for clarification or approval over something. When I'm asking for something and I don't have a high degree of confidence that I think it might know what I want, but I think it might have some misconceptions, I often just say, don't do anything yet. Demonstrate to me that you understand what I am looking for. Or I will say, ask me questions if anything is ambiguous. And oftentimes, um, it just tells me straight up, oh yeah, I'm not sure about this or this, and then I can clarify on those things. Um, some other ways, we can and should be converting data back and forth between different formats. Some formats are very machine readable and some are not. So, um, what I often do is, so let's talk about machine readable formats versus not machine readable formats. Handwriting is something that we humans have been doing for a long time. Um, and computers can read handwriting with OCR, but they're very inefficient with it. There's a lot of inaccuracies, and they're much more efficient at reading things like text documents and digital files. Well, what we can do is we can use AI to convert handwriting into text files and correct the inaccuracies. But once it's in a format that's more machine readable, then now the machine can parse it and it's less ambiguous and it can read things that would take me a very long time to read. It can read entire books in fractions of a second. These are all powerful things. Um, Or if you wanted to go even faster, you can store it in a database, right? If you have huge data sets, it's going to be very slow to have that in a bunch of text files. Better to have something that's queryable in a database. Well, databases are great, but you're trading off, and now it's less human readable and it's more machine readable. Well, depending on what you're trying to do, that could be a good thing or a not so good thing. But the thing that is really great now is it's never been easier to convert between different formats. You shouldn't be locked into one format. You can, if you have a task that would be easier to deal with a human, then convert it into a more human readable format. If you have a task that is extremely, extremely repetitive and you have it in a very human readable format, then try turning it into a machine readable format first, and then just have the dumb machine do all of that. And you can constantly switch, and it's going to make it much faster and much more reliable, right? Okay. The last thing I want to talk about, I I'm not going to be super in depth on this. I'm not going to be I'm not a historian, um, but I just want to leave some encouragement uh, to all of you that within the history of computers, we've had several times where there was a huge shift in computing, and it was pretty scary. A lot of people said, "Oh no, AI is going to take everything. We're all going to lose our jobs." Well, we haven't lost it yet, and many times that we did say that it was all doom and gloom, it actually turned out to be booming and better. But things did radically change, and we did have disruption. So, some of these I'm sure you've already heard of. Um, for example, um, in banking, we used to have lots of tellers at every bank, and they would do your transactions. And then ATMs came out. We had automatic teller machines, and a lot of people were saying, "Oh no, they're automating the teller job. Are we going to lose all our other jobs?" Well, yes and no. It's been a mixed bag. We have far less tellers than when I was a kid, but we still have tellers, right? ATMs can do a lot of different banking um, tasks, but they can't do everything. We still have things that we need humans to do banking on. There are some, this is always what happens. We're able to automate a lot of things, but there's always very strange edge cases that we need humans to work out. Well, if we look way back at the beginning of computing, we had mechanical machines, like IBM had mechanical calculators, believe it or not. They weren't even electric yet. They had switches and levers, and they were all metal, and they could calculate numbers, right? They could calculate things like the trajectory of cannon on the battlefield or doing banking things. Later on, we added a uh, abstraction where we started using punch cards. Before punch cards, we would have to physically manipulate the machine, but now we could put in instructions as holes in a punch card, slide the punch card into the machine. Later on, we had machine code, and now we don't even have to put in the punch card. We can flip switches and type in commands. Um, and so this allowed us to make programs much easier, but it was still really hard because you had to know binary, you had to do all these complex mathematical things, and it wasn't very natural. So eventually, we made assembly language. And instead of just putting in ones and zeros into the machine, now we could put commands like, I want you to move this number from this register to this register. It felt much more intuitive and human, but you still had to actually understand how the processor worked. And whatever instructions, machine code instructions you put into this computer, they wouldn't work on this computer because they had different architectures. Later on, we had assembly language, and now I could write something in the same code, and if I have a compiler for two different computer architectures, well, I could write it in one language like C or COBOL or Fortran, and then the assembler would take my programming language and then put it out to different computers. Those were great, but you had to manage memory. So then we have higher level languages like JavaScript and Python, where now I don't even have to think about managing memory. It manages the memory for me, right? And then fast forward to today, now we have large language models where I can just tell it intent. I can tell it what I want my uh, website or app or whatever to look like and do, and then it will figure out how to implement it for me. Now, each one of these, what we did was we abstracted away a bit of complexity. There's something that humans had to figure out how to do on their own, and now that little part of it is being handled by a machine. And that is a bummer for the people who are experts in that one area, but it is also a positive because now we can move on to bigger, more challenging tasks and problems. And by the way, you can still handle those complexities if you want. We still have people writing machine code today. The point is not, oh, it's horrible, we're all losing our jobs because we can't write machine code today. No, you totally can. The thing is, if you want to write machine code, now you still can, but you don't have to write machine code. And that's the unlock. Now that you don't have to write machine code, now you can write crazier things like websites or video games or all kinds of things. So, what I'm trying to say is that this has happened before. We've had times in the past where we added on layers and layers and layers of abstraction. And this is going to happen more in the future. We're going to have more and more layers of abstraction. If you built your career and your identity off of one particular layer of abstraction, and overnight it's irrelevant. Well, first of all, you can still do that thing. You don't have to stop doing that thing. But second of all, now you don't have to. Now you can move on to other things that maybe you couldn't do before. I would encourage you to look for what is that thing that I couldn't do before that I can do now. And maybe I can find something that is fulfilling and great in that direction. Um, you have so much to offer that no machine can offer, that no AI can offer. No machine or AI will ever be a substitute for you. Unlike them, you can learn from genuinely new and never before seen circumstances. What they can do is whatever's in their data set. Unlike them, you have an actual story and an actual lived experience. For example, if you are a musician making original music, actually care about your story. When I listen to your song and there's an incredible emotion in your song, I want to know what made you write that song. If I find out that your song was just a algorithmic output from Suno, then I am incredibly uninterested because I already know the story that led to that song. Somebody wrote a prompt and then an algorithm output it. But if you actually are a person with a story, that's something that I care about. That's something that humans have that AI does not. Lastly, people can care about other people and people can care for other people. But no machine will ever care about you in the same way that a person can. So please do not replace the people in your life with machines. No AI girlfriend is ever going to love you like a real person. And you will never care about a machine in the same way that you can truly care about a person. Those feelings that you might be feeling for some AI, they can feel really real, but they're just manufactured and they are an approximation of a real thing. But when you have actual loved ones in your life, other people, then you will realize that the AI feelings, the feelings that you have for the AI, that's just counterfeit. It's nothing. So look for what really matters. Look for what cannot be fake.